Hi, my name is Marcus Jones,
Brajan Sykes.
Kayvona Davis.
Derek Smith.
and this is our physics project.
All right, today we're going to be going over the work done on a frictionless incline. Work, as we know, W is equal to force times distance. On this frictionless incline, the incline is at a 45-degree angle. So we're going to do cosine 45 degrees. All right? And all this work is going to be exerting a force of a 4 meters, of 4 meters, I'm sorry. So we have the person, which is exerting a force at 1,267.7 newtons. We have a person that he's exerting the force on, sitting down in a chair. The person is 72.6 kilograms. The chair is 9.1 kilograms. All right, and it's going to be going up an incline of 4 meters at a 45-degree angle. All right, so we have all our givens and we have a couple of unknowns, right? So one of our given is the force, which is equal to 1,267.7 newtons. And then we have our M1, which is the human that is getting the force exerted on, which is 72.6 kilograms. And then our M2 is going to be the chair, which is 9.1 kilograms. All right, and we're gonna do an M prime because the M prime is going to be the total amount that's getting pushed up on, which is M prime 81.7 kilograms.
To continue the problem, we're given the equation that W equals force times distance, work is equal to force times distance. We know that force is equal to mass times acceleration. We're already given a mass, we just didn't have the acceleration. So in our next step to find the acceleration, we took our given force of 1,267.7 newtons and we divided it by our mass, which is 81.7 kilograms, which gave us a full total for our acceleration of 15.5 meters per second. Force, once we find our acceleration, we can now calculate the entire force, which would be 81.7 kilograms times 15.5 meters per second, which would give you a full force of 1,267.7 newtons.
Okay, then to calculate the work, we have the force, which is 1,267.7 newtons, times the distance, which is 4 meters, also times cosine 45, which is our angle. So we multiply that, we're gonna get 5,070.8 joules times the cos 45 degrees, and then we're gonna get the work 3,585.6 joules, which is our final answer.
So a quick overview about what we just did to find the work. We have our main things right here, 1267.7 newtons for person A. We have 81.7 kilograms, including the chair for person B. And then right here, for our force is equal to M times A. We have our equation right here. 1267.7 newtons divided by 81.7 kilograms is going to give us our total acceleration of 15.5 meters per second. And then right here we have our total force of 1267.7 by multiplying the 81.7 into 15.5 meters per second. And then right here we have our work time equals the force times the distance. And then here's our equation to get the main thing work, which is 3,585.6 joules.